guys, good morning, good afternoon, good evening. Welcome to Prof. Sam channel, and today we're talking about topology by Prof. Sam. You can subscribe that in my YouTube channel. So today I'm going to deal with definition of topological space. So just like any other unit that you deal with in the campus, topology begins by definition of what topology is. But in this respect today, I'm not going to deal with the definition of topology. I'm going straight to key areas that are normally covered just like any other unit in campus. So when we talk about topological space, guys, we're simply talking about a pair. A pair, let's say, X tau. So topological space is simply a pair X tau, whereby X is a set and tau is a collection of subsets of X. So in this respect, I'm saying, number one, that we are considering a pair X tau, and X is a set, tau is a subset of the collection of the sets of X. Now, what I mean is that more than that, there are other three axioms that must be fulfilled for any collection to agree to conform into the definition of what a topological space is. And those are the key areas that I want us to highlight. I repeat, I'm saying a topological space is simply a pair X tau, whereby X is a set and tau is a collection of the sets, or rather the subsets of X. And this must fulfill the three axioms, three rules. Number one, let me just put that down first. X tau, saying a topological space is just a pair X tau where X is a set. So X is a set and tau is a collection of the subsets of X that satisfies the three axioms or rules. And I'll just say number one. So we are saying that simply a topological space is defined as a pair. It is just a pair of X, let's say a set X, and a collection of the subsets of X, which we are laying it down to name it as tau. So we have X, which is a set, and then we have, of course, inside the set X, there are other smaller subsets. And then we are saying the collection of these sets of X form up what we call the tau now. Now, the X and tau, which is a collection of the subsets of X, must fulfill three axioms. So the axiom, these are rules that will guide the topological space definition. So number one is that the empty space, that sign shows empty space, and X must be in tau. So what we are saying here is that for any pair X tau to fulfill the mandate of being called, being referred to, being defined as a topological space, rule number one that this must satisfy is that the empty space and the X itself must be in tau. And we say tau is simply a collection of all open sets of X. I repeat, empty set and X must be elements in tau, whereby we say tau is just a collection of elements of X. That's good. Then number two, we have now number two, the axiom number two, that any intersection of um, any intersection of X of subsets of X must be in tau. So under axiom number two, we say that if we make any intersection, I'll do videos on intersection just after this, that any intersection of the subsets of elements of X must be in tau. If we intersect two or more arbitrarily, any elements that we intersect, these elements must result into what is in tau. Then the axiom number three, let's look at axiom number three. This is the rule number three. For any pair to qualify to be called a topological space, then any arbitrary union of elements of X must be tau. So here we are talking about intersection. The second one, the third one, we say union. Arbitrary union of elements in X must be in tau. So to define a topological space, axiom number three, rule number three, is that if we take union of elements in X, any element in X, we must result into the collection. Those elements must give us what is in tau. Let's take maybe an example. Let's say we have our set A is 1, 2, 1, 2. Then set B is, let's say, say set A, that one. Then set B, let's say set B is 2, 3. And then tau, let me just clear this, sorry. So guys, for us to be able to understand more deeper on intersection and union, I want to ask you to log into my YouTube channel, that's Prof. Sam, and then check out the videos that I've done on these two. And that will be able to explain to you it's just a continuation of what I was explaining here to avoid having an elongated video. Thank you. Welcome. Have a nice time.